Let's take a look at slope. Now we have a line, and it's going like that. Well, it's got a certain steepness that goes at. Excuse me. This is referred to as slope. And let me try to write that a little bit more legible. Sun was in my eyes, that's why I couldn't write that. Okay, there we go. And slope is represented by little m, and it's the change in y over a change in x. Now, some instructors will teach us as rise and run and so forth. I don't like that form. I like this better. Realize that slope is a rate of change, and you can put anything in here. Change in profit over change in time. Change in finances over change in time. Change in miles over change in time. Miles per gallon. Change in miles over change in gallons. So you can put anything in here. Now, taking that into account, all we're going to be looking at is x's and y's, but it's much more than that. A huge part of calculus is studying this right here. Now, if you're given 2 points, x1 and y1, and x2 and y2, then your slope, there's a formula. Your slope is y2 minus y1 over x2 minus x1. Now, if I were to draw the line between 2 points, so we're given 2 points, like what we're given right here, and draw a line through them. If it's going up like that, then m is positive. It's increasing from left to right. If I were to connect 2 points, and it goes like that, then m is negative. It's decreasing. Now, if I have this right here, where it's a vertical line. Now, if you remember this from before, vertical line is when you got x is equal to a number, like x is equal to 3 or x is equal to 4. When you got a vertical line, m is undefined. And if you got 2 points and you draw a line between them, and it's straight across, a horizontal line, this is of the form y is equal to a number, like y is equal to 2 or y is equal to 3. In that case, m is equal to 0. Let's look at a problem. And this is at 4-1. Right there. And then -2, -4. 1, 2, 3, 4. Like that. And lines through them. And it says, find the slope of the line whose graph is given. Well, remember, slope is the change in y over the change in x. So change in y over change in x. So if we start with one of slopes, let's start with this one up here, and change in y. So we're gonna try to move from this point and get to the other point. So we're gonna go 1, 2, 3, 4, 5 down. So down 5. And then from that place right there, we're counting our tick marks. We'll go 1, 2, 3, 4, 5, 6 over. So 1, 2, 3, 4, 5, 6. So left 6. And there we go. Got a bug in my room. I was trying to kill it. You will die, bug. I'm not sure where you went to. Now down 5. What that is negative 5. If you go down, it's negative. If you go left, it's negative. So this would be negative 6. So our answer would be 5, 6. Okay, let's look at it another way. Instead of starting there and going down, let's start right here. And we're going to go up and into the right. So I'm going to go 1, 2, 3, 4, 5. So I went up 5. And then I'm going to go right. So I go 1, 2, 3, 4, 5, 6 to the right. So I'll go right 6. Okay, now if we're going up, that means it's positive. So this will be a positive 5. And if we're going right, then that's positive. So we've got a positive 6, which would also give us 5, 6. So again, if you're going down, it's negative. If you're going left, it's negative. If you're going up, it's positive. If you're going right, it's positive. Now you notice it doesn't matter which point we start at, we end up with the same slope. So that would be your answer. It's 5, 6. Excuse me. Okay, this says plot points in a rectangular coordinate system. You can do that if you want, if you're not comfortable with plotting points. Draw a line through them, and it says find and interpret the slope of the line. We're just going to find it. Interpret it, if it's increasing, decreasing, positive, negative, so forth. Well, if given 2 points, this is x1, and this is y1, and this is x2, and this is y2. And our slope is given by this formula, y2 minus y1 over x2 minus x1. It's a good idea to go through and replace your variables with sets of parentheses. Is your first step. And then we'll plug in our values. y2 is negative 7. y1 is 5. x2 is negative 5. And x1 is 3. Well, negative 7, negative 5 gives us negative 12. Negative 5, negative 3 is negative 8. Now, negative divided by negative becomes positive, so those negatives cancel. And top and bottom here are both divisible by 4. So that gives us 3/2. And that's our answer. Excuse me. Grab a drink. Of course, it's positive, which means it's increasing from left to right. Let's look at our next example. So we got negative 2 and negative 4 and 6 and 10. Well, let me label these. This is x1, y1, x2, y2. And our formula for a slope is y2 minus y1 over x2 minus x1. You'll find that whenever you're using a formula in math, if you write it down every time you use it, it'll help cement that in, and it'll just become second nature to you. Now, it's especially handy if you mess up on signs to go ahead and replace your variables with parentheses first, and then plug in your numbers. Now, we said y2 was 10, y1 is negative 4, x2 is 6, and x1 is negative 2. Now here we got a negative parentheses negative. That becomes a positive. So we got 10 plus 4. And down here we got a negative parentheses negative. That becomes positive. So we got 6 plus 2. That gives us 14 over 8. And both those are divisible by 2. So 14 divided by 2 is 7. And 8 divided by 2 is 4. There we go. And that's our answer. Let's take a look at this. Excuse me. Got 1/2, negative 1/3, and 5/2, and negative 2/3. And the same instructions, find the slope. Well, this is x1, this is y1, this is x2, and this is y2. Our formula is y2 minus y1 over x2 minus x1. So I go through and put parentheses where my variables are. Then I'll plug in my values. We said y2 is negative 2/3. y1 is negative 1/3. x2 is 5/2, and x1 is 1/2. Well, here we got a negative parentheses negative. That becomes positive. So we got negative 2/3 plus 1/3. And here we got 5/2 minus 1/2. Now the top part has the same denominator, so I can combine together the numerators. Negative 2 plus 1 gives us negative 1/3. The bottom part has the same denominators, so I can combine together the top parts. 5 minus 1 gives us 4/2, which gives us negative 1/3, and 4 divided by 2 is 2. Now there's nothing special here. We're going to see later on how to solve these, but how to simplify them. But here we have a negative 1/3 divided by 2. Well, if we're going to divide fractions, they both should be fractions. So I'll rewrite the 2 as 2 over 1. Remember, we never actually divide. We immediately rewrite it as multiplication. So I'm going to take the 2 over 1 and rewrite it as 1/2. Now we multiply the top parts together. Negative 1 times 1 is negative 1. And the bottom parts, 3 times 2 gives us 6. So that would be our slope. Now let's remember our oddball cases. I'm going to do it with an example. X equals 3. We've already said x equals a number is a vertical line at that number. So that'd be a vertical line at 3. Now if I look at any point on this line, it'll be of this form. 3 and then some kind of y value. The x part will always be 3 no matter what. So if you're actually given 2 points, like some of these problems we just did, where you're given like this right here, it's one of our oddball cases. Since the x values match, it's automatically the equation is x is equal to 3. It's a vertical line, and your slope, remember, is undefined. Now if you got y is equal to 2, remember the graph of that is a horizontal line at 2. So it looks like that. M is equal to 0, of course. The key part here is I don't know what the x value is going to be, but I know what the y value is. It's 2. It's always 2. And again, if I had another point, it'd be something here, and we'd have 2 here. So the x values can be anything, but y is always 2, or whatever value, whatever number you have. Well, let's take a look at some examples using these. Looks like this is a vertical line through negative 1. Well, remember what a vertical line is. A vertical line is x equals a number. And it's x equals whatever number it passes through. So it passes through negative 1 like that. Now specifically here they're asking us to find a slope. Well, the slope of a vertical line is undefined. So that would be our answer. M is undefined. Okay. We're given negative 4 and 2 and negative 4 and 5. Now I'm going to go through the steps on this, but first I want to talk about the shortcut. Look at these points here. You see anything unusual about them? the x parts are the same, aren't they? They're both -4, which means this equation is x equals -4. Because the x values are the same, it's x equals whatever that number is. If the y values were the same, like if this was 2 and this was 2, we'd have y is equal to 2. Now remember, for x equals a number, it's a vertical line at that number, so m is going to be undefined. But let's plug this into our formula and see what we get, and y would be undefined. So this is our x1, this is our y1, this is x2, and this is y2. Remember, our formula is y2 minus y1 over x2 minus x1. Before you plug in your numbers, you should put parentheses where your variables are. There's that bug. Yeah, he got escaped again. Afraid he's going to get my drink. That's why I'm even worrying about him. Okay, so y2 is 5. Got a lid on it. It's a pop from Casey's. And y1 is 2. x2 is -4, and x1 is -4. Well, up on top, 5 minus 2 is 3. And down below, we got a negative parentheses negative. That becomes a positive. So this becomes -4 plus 4. And -4 plus 4 gives us 0. Well, anytime you have a 0 in denominator, that's undefined. So if you go through if you don't notice that it's one of the oddball cases, if you go through the steps, you're gonna see that it's undefined, and that'd be your answer. Let me change my seating pattern here. There we go. And let's look at our next problem. This is a problem getting us used to what the slope is used for. Okay. It says draw a graph of the line that contains a given point and has a given slope. Well, we want to write the slope in the fraction form. So this will be 2 over 1. Now remember, this is the change in y over the change in x. If our y is up and down. If it's a positive 2, then that means up 2. If it's a negative 2, it would be down 2. Now this is our change in x. And if it's a positive number, it's right. So this means right 1. And now if it was a negative 1, we would go left 1. So in this problem, what we're going to do is we're going to go put a dot at this point. So -2, 4. And put a dot there. Now from that dot, we're going to use our slope to get our second point. That says we're going to go up 2 and right 1. So up 2, again from this point, I'm going to go up 2 and right 1, and that's where we put our second dot. Now after you get your second dot, you draw a line through them, and that would be your graph. Again, they're just kind of getting used to what the slope is used for, what it represents, and so forth. Let's take a look at another one. We got 1, -2, and m is equal to 4/3. Well, again, we want our slope to be in fraction form, and it is. And this is y, and this is x, changing y over changing x. Now this is a positive 4, which means we're going to go up 4. If it was a negative 4, we'd go down 4. Well, this is a positive 3, which means we'll go right 3. If it was a negative 3, it would go left 3. So let's go put this point on here. So we got 1, -2, which would be right here. Now from there, we're going to use our slope to get our second point. So that says we go up 4, right 3. So I'll go up 4, so I'll go up 4 units, and I'll go right 3. And that's where I put my second dot. And after you get both dots, you draw a line through them, and that would be your answer. And I believe that's the end of the section too. It is.